Hello, everybody, and welcome back to another episode of the Lil Dudes Insect Academy podcast. I am so excited to be here with Jill Joyner and Alyssa Branca, and we are here at the ESA conference in Washington, D.C. So welcome to the show, Jill and Alyssa.
Thank you. It's great to be here.
Hi, yeah, nice to be here.
Yeah, so we're going to just go ahead and get started. So we're going to go ahead and get started with just introduce yourselves a little bit. Like, what are you doing right now and kind of your path to get here?
So I'll go first. So this is Jill. I am a research entomologist at Banfield Bio. We're a really small research and development company just outside of Seattle, Washington. And yeah, right now our main focus is kind of developing tick traps and finding ways to help control really arthropods of medical importance. So mosquitoes, ticks, kissing bugs. And so I really work on, just developing ways to test our products currently.
Very cool.
And my name is Alyssa Branca. I also work at Banfield Bio, and I am the research biologist there. And I will do everything from just lab bench work to field work with arthropods. I do a lot of grant writing, as does Jill. And one of our overall goals of the company is to help facilitate moving academic ideas into commercial products. And so I've worked on mosquito traps that have made it into the field in time to help trap the mosquitoes that cause Zika virus when that broke out in Puerto Rico.
Yeah.
And yes, now we're working on tick traps. We're also, we're willing to work with any sort of arthropod. If people have an idea but they're not really sure how to get it to that next step, we can often help with that, and we can help facilitate partnerships with other academic institutions that, somebody working in Texas might not realize there's somebody up in Washington working on, or out in Connecticut or something.
Very cool. Okay, so let's go into a little bit about your both of your past careers. So let's start with you, Jill. Where did you go to school? How did you and how did you choose where your path went?
Yeah, so I did my undergrad at the University of Washington. Really wasn't entomology focused at all. It was very much just basic entomology, but I interned in a lab that focused on mosquitoes.
Nice.
And then after I finished my undergrad, the people that I worked with in that lab, they forwarded me an email about a PhD in the UK to then do more work with mosquitoes, mainly for egg-laying behavior. And they really helped me with that application and everything. And then I kind of applied on a whim, and I got it. And then they're like, "Can you move to the UK in 2 months?" And I was like, "Okay, sure."
Wow.
So moved there, and then continued on into entomology and focused on mainly insect behavior, a bit of a chemical ecology focus as well. And then finished my degree, and then I got a job at Banfield Bio. So I'm still really fresh in my career, but it's been exciting to I didn't think that I would go into entomology fully, and then it kind of just happened, and it's been great.
Very cool. All right, how about you, Alyssa?
Well, I took kind of a different path. My original undergrad degree was in comparative literature at the University of Washington.
Okay.
I worked for a while for a company that harvested government bids and RFPs, and we'd package them up, look through line-by-line details, and send them out to people who were interested in, this topic or that. And I got a little frustrated with it. I was like, I kind of want to learn more. I want to go back to school. And I ended up going back to the University of Washington and got a bachelor's of science in biology. And while I was there, I studied the crow roost at the University of Washington Bothell. And I was like, is the crow roost having an effect on the creatures that might be living in the leaf litter underneath? So I was going through and sampling soil and leaf litter and putting the stuff in Berlesi funnels, and then just looking at all the bugs and stuff I found. And after I graduated, I went and looked for a job, and I was like, there's an insect, a pest control company that's kind of nearby. And I didn't expect to be looking at bugs. in the first place.
Yeah.
And I did not expect to find a job working with bugs. But, I applied, and it was super exciting, and then it was this place where I could also, use my literature background to help write grants. And,
Yeah.
And, there's a lot of writing that happens in science.
Right.
So it's kind of like two of the things that I was super interested in, and it's been really a very interesting, fun place to work.
Very cool. Yeah, so it kind of all works together and everything's kind of connected a little bit. Very cool. Yeah, so where did you two originally kind of, we talked a little bit about when you originally got interested in entomology, but kind of what drew you in? Was there a moment that you really got hooked on insects in general?
Well, I guess, so growing up, I was always kind of digging around, lifting up rocks and looking at, the ants that are under there.
Right.
There's a field right behind my parents' backyard that there's this one summer I remember catching so many praying mantises. And sadly, I don't remember seeing many praying mantises after that, so that's kind of really sad that I did that. But, so I feel like it was kind of the interest in entomology was always there.
Yeah.
It didn't ever occur to me that it could be a career until I went to college.
Right.
But yeah, it very much was always kind of persistent, and it really blossomed later when I got to experience actually being in a lab and researching mosquitoes, and then kind of branched out further from there. So.
Yeah.
And I too was one of those outdoors bug kids. Just in general, if I could find something cool outside, I'd go look at a bug, or there's maybe there's some newts in a pond or something. I had family growing up in Kansas, so we'd go back there and we'd get to see lightning bugs.
Yeah.
And that was really cool for a kid from Washington State, where we didn't really have
them. Yeah.
That. So. Always kind of interested in the natural world, but didn't know that careers were possible in it at all.
Right.
And again, I kind of stumbled into it, but really enjoy it. I don't know, it's kind of cool seeing these horrible infectious diseases, but something relatively simple like a trap can just prevent people from catching it in the first place. And I just think that's super cool.
Yeah. Yeah, so let's get into that a little bit more. What are some of the traps that you guys have been working on, and how has that kind of evolved over time?
So I'd say the main trap that we're working on right now is a tick trap,
Mm-hmm.
And that it's a CO2-based trap, and it aims to, I'd say, less for control right now and more for surveillance is the main goal of using it. And it's very easy to use, or you just set it out, and the sticky that catches the ticks is face downwards.
It prevents a lot of bycatch. You aren't worried about catching a bird or something.
Right.
And then you just kind of leave it out for a few hours and come back and see what ticks you've got. And so far, at least for the Lone Star tick, it does really well, because Lone Star ticks move a lot. And
we got data on black-legged tick as well, at least in the Midwest.
Nice.
And it did pretty well there as well.
Yeah, and
Very cool.
say how that has evolved a bit is before it was just kind of this wooden contraption, and now
a
it's
wooden contraption with a 1-gallon Coleman type cooler on it that somebody drilled holes in.
Yeah.
So pretty expensive.
Yeah.
Now it's kind of a more well-designed, looks like plastic, almost like a dog bowl is what it looks like now. And right now what we're really kind of trying to develop is something that source of CO2 that's not dry ice. Because dry ice is pretty expensive.
You have to have special gloves or tongs or something to handle it.
Yeah.
And you have a huge cooler you got to take out to the field.
Yeah, so now we're trying to figure out some way for a simple, easier way to produce CO2 over a long period of time. So that's kind of where that's been evolving, and with the goal that it's easy to use, cheap, so just mass surveillance of ticks can happen throughout the country, which would be great. And another trap that we're dealing with is...
When I started with the company, we were actually working on commercializing the CDC's oticidal gravid ovitrap for Aedes mosquitoes. They are container breeding mosquitoes that spread yellow fever and dengue fever, Zika virus, chikungunya, all sorts of nasty little diseases.
Yeah.
And those container breeding mosquitoes, they have this habit of going from one tiny little pool of water to another and laying a few eggs at each location. It's called skip oviposition. And this trap is designed to be a nice, cool, well, actually it's pretty boring, but it's a nice dark place which is really appealing to them. But they go in there and then they can't get to the water, and so then they fly up and go to rest on the walls and get stuck on the glue there. And they're very effective. I can't remember the exact numbers, but they were used in just a massive study in Puerto Rico by the guy who designed it, a man named Roberto Barrera. And his team. But they decreased the overall population of Aedes mosquito down to something like less than one per week or something like that on average, like super reduction.
So that has a bit of a different purpose. It's just to catch them and, more so eliminate them than versus the tick one, which is surveillance, right? Is that correct?
Right.
Okay, yeah.
Yeah, if the tick trap could control the ticks, that would be awesome. But just the way tick populations fluctuate. And it's so much more difficult to do that with just a trap.
Right.
Yeah, ticks can get dragged in from anywhere by all sorts of different animals. And,
Yeah, so you said that so let's go back to the tick trap. It's CO2 based. So what attracts the ticks versus, what attracts a tick specifically versus anything else?
So with arthropods that are blood feeding, CO2 is used as a very main source of attraction because, things that are breathing, for the most part, they have
expel CO2, right, yeah.
So for mosquitoes, kissing bugs, bed bugs, and ticks, CO2 is used as a main source of attraction to get them towards the source that we're trying to lure them to.
Right.
Versus, because other insects, they don't have as much interest in CO2. There's maybe a bit of expulsion from, plants, but it's so minor that it's not as large of an attraction as it is for blood-feeding arthropods. So that also helps reduce the amount of bycatch that we get as well, because other insects just aren't really interested in the CO2.
Yeah, it narrows it down a lot. Yeah, I see what you're saying. Okay, yeah, and then the second one, the mosquito one, what is the main attractant for that?
Stinky water.
Oh, really? Oh, yeah.
Yeah, so basically we tell people to fill it up. I think it's probably about 2.5 gallons or so.
Oh, wow.
And then throw in a handful of leaves if you're in New Jersey, or a handful of local grass if you're in Florida or Puerto Rico, just sort of native vegetation. And after about a week or so, you're going to just have a real gnarly smelling blend, but it's very attractive to the mosquitoes.
And that sort of attracts them for a place to breed, or?
Yes.
Okay, that makes sense. Yeah, so correct me if I'm wrong, but the females are the ones you're worried about, right?
Correct.
Because they're the ones who feed, right? Okay, so it attracts. So the main ones that you catch would be females then, because they're attracting because they're attracted to a place where they can lay their eggs. Is essentially what is happening. Okay.
And with oviposition traps, what's great about them is you're kind of targeting. You're kind of canceling out two things with mosquitoes. So one is a mosquito is only able to infect someone with a disease that they've already bitten someone, right?
Right.
And they only bite someone when they are looking to then become gravid and then lay eggs.
Right.
And so one, you're catching the mosquitoes that have bit someone, so the ones that are infected, but then also you're catching mosquito that's going to then be producing. So you're canceling out the mosquitoes that have disease and also the reproduction of the mosquitoes as well. So you're kind of doing a two-punch when you set out oviposition traps, so rather than just host-seeking traps or sugar-feeding traps.
Really? Okay. Yeah. So after you've left the trap out for how long?
The AGO trap they were getting left out for probably, months on end, and then we were replacing the sticky every month or so. It was about 4 weeks that they get maintained.
Yeah. And then how many individuals are kind of an average catch, I guess?
Ooh, that's a good question. We were often looking at just Aedes mosquitoes as the mosquito of like that we were really looking at, and sometimes it was as low as like one per trap week.
Right.
But it caught quite a few other species, like several in the Culex genus, probably some others in there as well. They're attractive to more than just the Aedes mosquitoes, but
Right.
I'd say like we'd probably get like hundreds on the cards
Oh, wow.
when they get checked. I don't have an exact number though.
Yeah. Very interesting. Yeah. So how about let's go back to a little bit of what you guys have done in the past. So what were some of the projects, just name a few of the projects that you guys have kind of worked on in the past, both in your school or otherwise?
So I guess during my PhD, it was very much on mosquito egg-laying behavior.
Yeah.
And so I was more kind of less on developing traps and means of control and more just like curiosity science, which is great.
Yeah.
And so I was really wanting to look at if the main species I was looking at was Aedes aegypti, so the one that carries like Zika and dengue. And I wanted to see kind of if where they laid their eggs, did that actually correspond with where their offspring produced the best?
Okay.
So and it's a bit more difficult with Aedes because, as Alyssa said before, they do skip oviposition. So it ended up being that where they laid their eggs is not necessarily guaranteed that it's where they're going to actually perform the best growth-wise, because, I mean, they don't really have to care about that because they lay in so many different things. They just go all over. So it's like, chances are some of my offspring's going to survive.
Right.
So that's really what I focused on. But then I also wanted to see, so they will lay their eggs kind of just above the water line, but occasionally they lay their eggs on the water surface as well. Because Aedes, when they lay their eggs just above the water line, then as soon as, after like a few days, maybe the water surface will rise, and then they hatch. So it also makes them, this is why they can be such a problem, because they'll lay their eggs in like tires, and then the tires will get shipped across the world, and then they kind of spread around.
Right, yeah.
And so I wanted to see if what was in the water also kind of helped correlate with whether they laid their eggs directly on the surface of the water or just above the water line, to see if they had a way to kind of optimize how well their offspring would do as well.
Interesting.
With that. And it looks like there was a slight difference between, like, based off of what was in the water, whether they laid their eggs just above the water line or on the water surface, but it still didn't really correspond with how well their offspring survived. So that's actually a benefit, I'm not sure.
Yeah.
But that's really what I focused on during my PhD.
Very cool. Yeah. How about you?
Well, when I was doing my work in college, I was just looking at just kind of an overall arthropod and kind of microfauna, not microscopic microfauna, but not, like the little bugs and slugs and worms and stuff you might find in soil and leaf litter.
Right.
And so I was just looking at everything there and trying to see if the crow poop changed like how things were laid out. That was kind of an inconclusive study. It was undergraduate research, didn't have couldn't throw 4 years of PhD work at it.
Yeah.
So, I mean, it's a very interesting location because there's a whole bunch of undergrad researchers there still looking into all sorts of aspects of it, but I don't know if anything conclusive has come out of it yet.
Yeah.
But once I got to Banfield Bio, I've done all sorts of things. I have counted, probably 40 or 50,000 yellow jackets that we've caught over time, and fruit flies. Looked into pantry moths as pests. All sorts of different things. I did a lot of chemistry making lures for products that we used to have a home consumer line that we've spun off from the company.
Right.
And so just any sort of kind of pest arthropod you can think of, we probably had something for it at one point or thought about making something for it.
Yeah.
But most of my work has been on mosquitoes and ticks at this point. We also looked at some different methods of getting incredibly small amounts of pesticide to very targeted locations. So with mosquitoes, we looked at auto-dissemination, where with these skip ovipositing mosquitoes, if you could get them to go somewhere and get, like, say, dusted with a powder, the original idea was kind of tarring and feathering them.
Oh,
so
really?
They'd walk through a kind of a liquid formulation,
Yeah.
and then they'd walk through a powder formulation and get it caught on them. And then when they go lay at, like, it was a trap that, it wasn't a trap. It was designed to get them in there, they couldn't lay, and then they would be forced out another way. And they'd get tarred and feathered and then go from, we'd put out cups to test this. And they'd go from cup to cup trying to lay eggs and also depositing a larvicide along with it. So it was a super cool idea, and there's still people working on it, and we've actually spun the idea into trying to use tick hosts to do something similar, although we're still in progress working on that. So nothing publishable yet.
Okay, very cool. I think we're going to wrap it up here pretty quick. What are some of the plans that you two have for the future? Like, what are some of your goals? Maybe fun projects or trips that you want to do? What are your plans?
Oh, okay. Does it have to be entomology related?
No,
Okay.
no, just in general.
So right before getting hired by Banfield Bio, I hiked the Pacific Crest Trail.
Oh,
That
cool.
was my, what I wanted to do right after the PhD.
Right.
So I'd say my next goal would be to do the Continental Divide Trail. And
Oh, really?
I don't know when, but that's, I think, my next main goal. Would
That's
be
awesome.
Pretty sweet, so,
Yeah, so you're into hiking and backpacking a lot too?
Yes, very much so.
Very
Yeah.
cool.
Yeah, it's been great. Try to go out as much as I can, but it doesn't always happen. So.
Yeah, that's so awesome. Yeah. How about you, Alyssa?
Oh, that's a good question. I would love to travel more. I have a 7-year-old, and I really want to install a love of learning in him.
Yeah.
And he already is very much interested in bugs, so I'm very excited to see
That's great.
the Lil Dudes program. I'm going to introduce this to him when I get back home. So I'd like to be able to travel and see some things and think about the natural world, and I think that's probably my goal for the near future, is going places.
Yeah.
Getting him excited about things like that.
That's really awesome. Yeah, all right. So thank you both so much for being on the show. One last thing before we sign off. Is there anywhere that the viewers can go to learn more about both of you? Maybe social media, if you have it, or anything like that, maybe a website, anything like that for either of you that they can go?
Yeah, so I guess for
we work at Banfield Bio,
Right.
which is banfieldbio.com. Right now it's mostly about a trap that we produce that's a monitoring trap for native pollinators. We're hoping to get a little more details on the
our website is currently getting a revamp as we speak.
Got it,
So,
yeah.
And then for me personally, I am not too active on Instagram, but my handle is Jill the Joiner, and I have some macro photography pictures and some
cool.
hiking pictures on there. So,
Cool.
Yeah.
Yeah, I'm on Twitter and Blue Sky at MJ12Ash. I very rarely use it. The handle is just kind of gibberish.
I totally get it. Yeah. All right. Well, thank you both so much for being on the show. This was really fun to get to know both of you. But yeah, I enjoyed this a lot. I hope you guys did too. This was really fun. So thank you both so much.
Yeah, this is great. This is my first
thank you.
podcasting experience.